Overall equipment effectiveness. OEE is one of the most commonly used measures in manufacturing. It is also the most debated and confused measure. BEET also uses OEE, and here is a quick explanation of OEE used in BEET. Let's look at the chart from left to right. Bar A is the total time available to the system. B is the unused and unscheduled production time. C is the planned downtime for maintenance or scheduled breaks. By deducting B and C's time from A, we get D, which is the planned production time. This is the base for OEE calculation. During actual production, you will have breakdowns, work stoppages, or faults as summed up in E. If the system runs in batch mode with different models, you might need to have model changeover time, as summed up in F. By taking E and F out of D, we get G, which represents available production time. The ratio between available production time and planned production time is availability, the first of three components of OEE. When you are making parts, the machine can be idle for different reasons. Blocked and starved are idle times caused by the next operation not ready to receive parts, and the previous operation not feeding parts. These times are captured in the H column. Most machine cycles will not run at the design cycle time. This overcycle time is captured in I. By subtracting H and I from G, we get J, which represents design production time. The ratio between design production time and available production time is performance, the second of three components of OEE. Not all parts produced by the line are good parts. The time spent on rework parts captured in K and scrap parts captured in L are times taken away from making quality parts. By taking K and L away from J, we finally arrive at M, which represents effective production time. The ratio between effective production time and design production time is quality, the third of three components of OEE. By multiplying availability, performance, and quality, we get the OEE of the system. Sometimes due to quality might be captured at a later time, people use operation efficiency OE in place of OEE to get immediate manufacturing measurables. Operation efficiency is the product of availability and performance. Have you ever heard the term standalone cycle time? We want to show you how BEET uses asset states to capture different types of cycle time. An asset's production time can be sliced into 6 different states, as indicated here from T1 to T6. Let's dive into it. We are only concerned with production time here. During production time, N1 parts are made during cycling time, and N2 parts are made during faulted time, a possibility. The average cycle time is the full production time divided by the total number of parts produced. This is very straightforward. Starved T6 and block T5 time are idle times that are caused by the asset's neighbors. Starved time is when the previous asset can't provide the next part, when the asset is empty. Blocked time is when the next asset can't accept the completed part from the asset, due to the successor not being ready. These time losses can't be attributed to the asset. Taking out the blocked and starved time, T5 and T6, and dividing by the number of parts produced, we get standalone cycle time. Standalone cycle time is the true measure of the asset capability. It should be used to compare with other assets' standalone cycle time to find the process bottleneck. Normally, people will stop here. We want to go a little further. The first is the absolute standalone cycle time. We want to measure without faults and out of auto. What is the cycle time for the asset? The absolute standalone cycle time is calculated by dividing cycling time by the number of parts produced during normal, not faulted out of auto, production time. The second is the design standalone cycle time. This is normally known as the line is designed with this cycle time. The third is the potential standalone cycle time. This is by benchmarking the top 10% of the fastest cycles over 90 days of production data to visualize what is the possible cycle time for the asset. Let's go through an example. Assuming these, design cycle time equals 60 seconds, average, actual, cycle time equals 80 seconds, potential cycle time equals 54 seconds, target OEE equals 85%, and quality is 100%. We can then get these. Design cycle time is 60 seconds, and design throughput is 60 jobs per hour, JPH. Based on the 85% targeted OEE, the net, or target, cycle time is 71 seconds, with corresponding net throughput at 51 jobs per hour. Since the actual cycle time is 80 seconds, the actual throughput is 45 jobs per hour. If the potential cycle time is 54 seconds, the potential throughput is 66.67. Here are the results we can then produce. Since quality is 100%, OE and OEE are the same. The target OE is 85%, and OEE is also 85%. The actual OE and OEE is 75%. The potential is 111%. There is an 11% potential in the line that goes beyond what the line was designed for. The first step in BEET implementation is digitization. We want to focus on when the asset is cycling, based on BEET's built-in analytics. We can then help you establish potential cycle time and reduce overcycle loss. During this stage, the optimized cycle time of this asset should be established. The entire distribution of asset cycle time should be able to shift to the left. We are aiming to improve the absolute standalone cycle time by 5%. After you get through stage 1 with the optimized cycle time, we can expand the focus to include out of auto and faulted time. We want to reduce the variability of the asset cycle time. This is illustrated by making the cycle time distribution taller and skinnier. Through stage 2, you might be able to improve the absolute standalone cycle time further. Now you will have a more consistent and optimized asset cycle time. Once the asset cycle time is consistent and optimized, we can look across the line and leverage BEET to build automated continuous improvement and predictive maintenance processes. BEET can automatically provide process improvement and maintenance items to help you maintain optimal throughput and reduce unplanned downtime. Thank you so much for taking the time to watch this presentation. We hope you found the information valuable and that it has been a worthwhile investment of your time. If you have any questions, comments, or want to give BEET a try, please contact us at info@beet.com.